So this one kind of comes from our very first two examples. If you look back, the first one we did, the terms were 1 over n squared. And the second one, it was 1 over the square root of n, which you can think of as 1 over n to the 1/2. So I'm going to generalize those two into the following one. For what values of p does the series (1 to infinity, 1 over n to the p) converge? So again, just think of this as a generalization of the first two examples. So I'm looking at p as being a power. And so I'm going to break this up into if p is negative and if p is not negative. Okay, so let's start with the case if p is negative. If p is less than 0, well, I said I always like to start with the divergence test, so let's just use the divergence test here. I'm going to compute the limit as n goes to infinity, 1 over n to the p. But p is negative, and it's my exponent. I don't like negative exponents when I'm taking a limit because it doesn't really tell me what's going on. So I'm going to move that term to the numerator and make its power now positive. So now that power is positive because p is negative, and a negative times a negative is positive. So imagine that that power is like 2. So if I was looking at n squared, what would the limit of n squared be? Infinity. So that's what I'm going to get here. Because it's in the numerator, I'm getting infinity for this limit. I got something that's not 0, right? Infinity is definitely not 0. So I now say that this series diverges by the divergence test. So the series diverges by divergence test. Okay? So if my power is negative, my answer was that it diverged. Okay? So I don't have to worry about negatives now. Now let's say I look at what happens if p is equal to 0. And let's go ahead and try to use the divergence test. 1 over n to the p, right? But this is now 1 over n to the 0. What's n to the 0? 1, right? Anything to the 0 power, well, other than 0, is 1. So this is really just the limit of 1. And what's the limit of 1? 1. It's pretty boring, but that's kind of nice here. Did I get 0? No. Anytime you get anything other than 0, your work is already done. The divergence test tells you that it diverges. So I can again say series diverges by divergence test. Okay, so if p is 0, it diverged. All that's left is now considering the case when p is positive. Okay, so let's look at that. If p is positive, if p is greater than 0, well, let's go ahead again. just like we did in the previous case, let's take and try to use the divergence test. 1 over n to the p. Now my power is positive, so it's going to stay in the denominator. So what's that limit going to be? 0. Anytime you get 0, my divergence test just tells me nothing. Divergence test inconclusive. I tried it and it failed me. So that means I'm going to try something else. No big deal. It failed. We're just going to try something different. So here's where I'm going to go ahead and use the integral test to compute this. So we're going to turn this into a function, 1 over x to the p. This is definitely continuous and positive. Continuous and positive on my interval 1 to infinity. I need to show that it's also decreasing. So to do that, we're going to turn it into a function. We're going to take the derivative. So this is x to the negative p. And what's my derivative? Negative p, x to the negative p minus 1. So if I rewrite that, I'm going to move the power into the denominator, and it becomes p plus 1. Is that negative or positive? The numerator, negative p. Remember, p is a positive value like 2. So the numerator is negative. What about the denominator? X to the p plus 1. Positive. So negative over positive means overall I have a negative. So this tells me this is less than 0 on this interval 1 to infinity, which tells me it's decreasing. Great. So I now know I have continuous, positive, decreasing, which means I can actually use the integral test. So the integral I want to compute, 1 to infinity, 1 over x to the p dx. Because I'm running short on time, I'm not going to actually compute this integral, but we did it back when we did improper integrals. So you can look back at your notes. This converges if p is greater than 1, and it diverges if p is less than or equal to 1. And I was interested in when the integral converged because I wanted to know when the series converged. It only converges if p is bigger than 1. Okay? So let me sum up all of this into one statement that says the answer to this question, 1 over n to the p, converges if p is greater than 1, and it's going to diverge if p is less than or equal to 1. Okay? So this series right here, it's given a special name, 1 over n to the p. This 1 over n to the p, it's called a p series. And now we know whenever a p series converges, it depends on the power of p. So you can compare this with the two examples before. When I had n squared, my p was 2, bigger than 1, so it converged, which is what we saw before. The second example, our power was 1/2, our p was 1/2. That's less than 1, and it diverged. That's what we saw before. Okay?